Hi, my name is Dawn Edelman, and I'm a teacher of biology and chemistry here at Upper Dublin High School. I'm also this year's state event supervisor for Fear Me Questions. I'm so sorry I couldn't be here with you guys today. I love Science Olympiad. It's a great experience for both myself and my students. It's what I love to do most in my copious free time. As a teacher, I have a lot of that. So if there's anything that you need during the season, if you need some clarification of rules, extra resources, need help with a problem, feel free to contact me directly at dedelman@udsd.org. And I hope to see you guys at regionals and states. So first of all, description of the event itself. Students that come to the event, they're going to get 30 questions. Those questions are going to be science related. They require fast, rough estimations in order to perform calculations to determine the value of something that can be measured directly, or more often, things that can't be measured directly. So for nostalgia's sake, and also to show you that other people are thinking about these really, really important questions, I'm going to show you a quick video.
Mr. Turtle, how many licks does it take to get to the Tootsie Roll center of a Tootsie Pop?
Why, he never made it without biting. Ask Mr. Owl, for he is the wisest of us all.
Mr. Owl, how many licks does it take to get to the Tootsie Roll center of a Tootsie Pop?
A good question. Let's find out. 1, 2, 3, 3.
If there's anything I can't stand, it's a smart owl.
How many licks does it take to get to the Tootsie Roll center of a Tootsie Pop? The world may never know.
Apparently now the world does know. Science, it would appear, does have the answer. According to a study published in the Journal of Fluid Mechanics, it takes about 1,000 licks per centimeter cube to reach the center of almost any lollipop, and based on that math, a Tootsie Pop, which is a little more than 1 inch in diameter, would need to be licked about 2,500 times for someone to reach the Tootsie Center. You heard it here first.
I don't know about you, but for me, it maybe 5 or so. In any event, the idea is that your students don't have to be experts in fluid mechanics or particle physics or anything like that. They have to know a lot of facts, right? And they have to be able to make some estimations and calculate. So moving on, right? This event was really named for Enrico Fermi, who was an Italian physicist. He was best known for working on the Manhattan Project and for making the first nuclear fission reactor. So he was crazy good at these estimations, and that's why they call these Fermi questions. They're some tangible, some intangible kinds of questions that he was really good at answering. Best known for the time that he was able to estimate the power of the energy that was released from the first nuclear bomb that was tested in the US. It was called the Trinity test. And during the event, he was holding pieces of paper in his hand that he let go when the bomb went off. And he measured the distance that they had traveled during the event. And using that and some other factors, he was able to calculate or make the estimation that the energy released from the bomb was equivalent to 10 kilotons of TNT. Later on, it was discovered that the value was actually closer to 20 kilotons, but not bad. He was only off by a factor of 2. And we're looking at factors of 10. So I'll explain that as we go along. So participants, we can have 2 per team, like many of the Science Olympiad events. Students can only bring a writing utensil. There's no calculators of any kind that are allowed during this event. They will be given an answer sheet, a task, and some scrap paper. They can write all over the scrap paper. They can request as much scrap paper as they want. We will collect it when they turn in their test, but we will not be looking at the scrap paper. We'll be recycling it. So any answers that are not transferred to the answer sheet will not be counted. The work won't be examined. So please remind your students, and I will do so as well, that their answers need to be on the answer sheet in order to be counted. We're also going to record the time that they turned it in the event that we have a tie. We're going to use that as our final tiebreaker. So quick rehash. scientific notation, right? So in scientific notation, what we're looking at is a coefficient that falls, it's greater than or equal to 1 and less than 10, right? Some number times 10 to a power. That power is the exponent. We're going to give you guys some rounding rules to help students with the reporting of their answers. And so the first one would be is that if they have a coefficient of 5 or greater, we're going to tell them to round this value up to 1, right? Because we want proper notation, and that will cause the exponent to go up by 1 as well. And so the answer here would be 6. So a rule of thumb would be if their answer when they write it out is not in scientific notation, have them transform it into scientific notation so that they can get an exponent to report, right? For those coefficients that are less than 5, we're going to tell them to round down to 1 for the coefficient and maintain the same exponent. So their answer would be -3. Those students that on their answer sheet write the full scientific notation form of their answer will receive 0 points. So please tell them that we only want the exponent itself. Scoring. So high score wins, right? Makes sense. If we have any tie scores, however, what we're going to do is we're going to look at those tests and see who has the greatest number of questions that were scored as a 5, right? If somebody meets the accepted value of the answer for a question, they receive 5 points. The next way to break a tiebreaker is if all the number of 5s are the same, we'll look to see how many 3-point questions, 3-point scores they got, right? And so to get a 3-point score, you have to be plus or minus 1 of the accepted value. Beyond that, we'll use the time that was recorded on their tests. Right? So if everything being equal, whoever turns in the test sooner will be advanced in front of the others. Okay. If you get within plus or minus 2 of the accepted value, you'll get 1 point. So here's a sample question, right? What is the average daily volume of rainfall on the Earth in cubic miles? Well, interesting fun fact that I was able to look up in the internet, your students don't have the luxury of doing so, is that the average daily global rainfall is really just 2 millimeters, right? That's not a lot, right? That's even taking into consideration monsoons and typhoons and all that kind of stuff, right? And so the answer when we calculate it out is 1.25 times 10 to the minus 15. So their Fermi answer is -15. Here's some sample scores. 1 times 10 to the minus 15, again, is in the full scientific notation form. That will receive 0 points. We only want the exponent. An answer of 15, right, would be 0 as well because they'd be off by a very large factor. They have to put the negative sign if the exponent is negative. Here we have somebody who hit the nail right on the head, right, that they reach the accepted value, so they get 5 points. Here's plus or minus 1 of the accepted value, right? 3 points, and plus or minus 2 of the accepted value, that would be 1 point. So the process. Students really need to be able to identify key factors that they're going to use to get towards an answer. Some of those factors are going to be hard to estimate, so they can break them down into smaller pieces. So I have a question for you. How many hot dogs are consumed at Major League Baseball games during a season? So that means all the Major League Baseball games. So here's a simple equation that somebody might use, right, to get to the number of hot dogs consumed. Well, they'd have to know how many hot dogs people usually consume at these games, right? And also the yearly league attendance. So I also looked this up, but they can make an estimate. Not everybody eats hot dogs, right? It was estimated that about 80% of the people do, right? So that would be 0.8 hot dogs per person. For yearly league attendance, right, that can be broken down into average attendance per game, right, times the number of games per season. And here's some values for you. I have an answer that I'm going to show you on the next page how I generated it. So the answer again, we have a coefficient that's greater than 5, so we round it up to 1 and then also raise the exponent. All right, so the final answer is 8. So how are these students going to prepare for the test? I'm going to show you one method that I think is really important. If they haven't been taught dimensional analysis, this is a great skill that they're going to use in science for the rest of their lives if they continue on in science, right? So dimensional analysis is just a way to solve problems, right, where we use conversion factors as fractions, and we situate them such that we can eliminate units as we go through the process so that we end up with our desired unit. So here is all the data that we had on the last slide. Notice that I have the number of games per season. I multiplied it by the number of people for games. Games would go away, right? At this point, if I had stopped here, I would have had people per season. Now multiplying by the number of hot dogs per person, people go away, and we have a number of hot dogs. Right? That's a lot of hot dogs. So again, here was our answer in scientific notation. Rounding up, we have a Fermi answer of 8. So what else do they need to know? They need to know the metric system, right? Try to create a wide variety of questions that have never been asked before. So we have to, use a lot of different resources to do that. So make sure that they know the metric system. That will go a long way with some of the questions. How to prepare. Establish some known facts. Now, I'm not going to click on these. You guys will receive this PowerPoint and you can do that at your leisure. But there's lots of good stuff. Right here is a list of, just different kinds of units of measure, like acres, right? So it's not all going to be metric. So make sure that they know what an acre is in square miles, right? And a variety of other things. Data. World population, government, economics, social media. This one's really cool, except for that it's updated like continuously. So it's not a static number. So it might be something they have to play with just to get some general ideas. Planetary facts. Planets are really large, so they're well suited for Fermi questions, ocean data, all sorts of really good stuff. I love this site, really interesting. By body system, it lists all sorts of really cool facts. So it's a good idea to get kind of familiar with different places where you can find this information. Why? Well, you got to make some really good assumptions, right? It's better if you know things. One of the examples that was given to me is like, know what the size of a piece of paper is. You shouldn't have to assume what the size of a piece of paper is. So the best assumptions are the ones that you don't have to make, right? No simple equations, volume, density, distance. We're not doing anything crazy here because this is a middle school, 9 to 12 grade level. In some cases, I guess 8th grade. So we're not going to, have people doing calculus on this task. Okay, so make sure they know simple equations. Be as accurate as possible. But keep in mind, right, you can be off by 50% and still receive full credit, right, because it's in that rounding of the coefficient. Also, you can be off by as much as 250% and still get some points for your answers. So it's really important to try to be as accurate as possible, but, there is some room there where you can still get points and not hit it right on the head. Partner selection. So this is where maybe you guys come in or your team captains, whoever's involved with that, right? You want to have 2 kids with maybe a diverse set of skills. First of all, you want somebody who is a really good estimator, right? Maybe a good spatial person, have those abilities to imagine size of things and so forth. So if they're good at making those estimations and knowing some random facts, it could really help the other guy, the number cruncher, to carry out the final task of answering these questions, right? They have to be logical and systematic. That's where that dimensional analysis comes in. It's really super helpful for them. Be able to work very quickly because 30 questions, what's the event these days? 50 minutes long, something like that. Time goes by really fast. And they should also know some conversion factors. And that's obviously a shared responsibility so that they can get to the unit that's desired for whatever's being asked for. So here's another funstrating problem. I love this word, funstrating. One of my students many years ago when we were doing this very work, I kept on saying, isn't this fun? You guys love this, don't you? He goes, I really do, but it's really frustrating. He goes, oh, they're funstrating, so I've coined that phrase ever since. I appreciate that from him. Here is another classic Fermi question. How much paper in cubic feet does the New York Times use in 1 week? So what are some of the assumptions we can make? Well, we have to assume what the population of New York is, how many people receive the paper, because not every person receives the paper. And if you have a family of 5, you're probably not going to get 5 papers, right? So you have to make an estimate there. Also, knowing the dimensions of the paper would be helpful too, right? Because we're looking for cubic feet, which is a unit of volume, and so we have to know the volume of the papers. Here's some known things that we could work with, right? We know the equation for volume of a rectangular prism, and that's kind of what a folded paper is like. We have some conversion factors we can use, and then we have to really think about it. Just like the hot dog one, we have to see, what are we piecing together here? So here we get the daily paper, you get it 6 times a week. And if we could figure out that volume and add it to the volume of the Sunday paper, then we can get the volume for the week, right? And once we have the volume for the week, if we multiply that times the daily circulation, we can get the total volume of all those papers. So here is a calculation. You can take some time to think about it. Of course, a student might do these conversions in their head. I'm just showing you what it looks like mathematically so that, you see the full picture and I don't leave anything out. And when we get to the end, we get 4 times 5 cubic feet, 4 times 10 to the 5 cubic feet. Again, this is too low to round up, so we'd round the coefficient down. Our final answer would be 5. All right, so here's the time when I really wish I was here with you to have a lot of fun. This is what I like to do. I really do. I don't know if that's a good thing or a bad thing. Here's some sample problems. Probably what you'll do now is maybe pause the tape so that you would take some time to work through these problems. Here are the answers that I have for you, and I certainly could send you the solutions, but the idea was to have you guys sit down as a group, right? Think about what assumptions you would make for each question. Make a list of things that you might know already, and then try to work towards a solution for these. So I guess with me not being here, you guys are free to get up and leave and go to your next session, or to sit around and mull around these questions and see what you can do with them. The next slide is just a resource slide where I got all my little graphics and things like that. So I'll advance that slide, but like I said, you can stop the video, you could play around with the questions, or you can go on to your next session. So I hope you had a fantastic day so far. Again, I'm sorry I can't be there, but know that I'm here for you, and anything that you need, just contact me at any time. Thank you.